Hello, family. Welcome to another session of Maths Fanatics, where we'll be looking at analytical geometry taken from a past paper. This question is suitable for both grade 11 and grade 12, right? However, if you are in grade 11, just quickly go, you are going to quickly skip 3.4 and 3.5. Those are only suitable for grade 12, but the rest of the questions, you can still do them because they are also examinable in grade 11. Okay, so let's get straight to it. So in the diagram, PQR is a triangle with vertices P, Q, and R. And we can also see that those coordinates are given here on the diagram, right? They form a triangle basically. Okay, so the first question they want us to calculate, okay, 3.1, they want us to calculate the length of QR. Okay, the length of QR. So this is how we're going to do it. Remember, length is distance formula, right? So QR equals to, you write the formula down, which is bracket x2 minus x1 squared plus y2 minus y1 squared, right? And then this becomes, now we're going to substitute. Ne? So my Q, I'm going to call it 1, 1, and then my R, I'm going to call it 2 and 2. Okay. Remember, a point, X is always the first and then followed by a Y, right? Any point that you're going to be given on a Cartesian plane, X first, Y after. Okay, so now I can see that, okay, let me just put this here. I can easily see that my x2 is 5. So where there's x2, I'm replacing with 5, and then my x1 is -3. Because I already have a negative here, the other negative, I'll put it in brackets, and then I have to close this bracket. Do you see it? Then I square, and then I have to add, like, I have to add y2, which is 3. And then I have to add y1, which is -3. And then I have to square both sides, right? And then now you can easily punch that on our calculator. Let's see what is it gonna give us. So you press square root in bracket. Okay, let's remove it a little bit so that it's visible. Okay, so we're gonna have 5 minus -3. Then you square, and then you add a plus in between, and then you have 3 minus bracket -3, and then you square, right? Then you get your answer. So your answer is what? 10 units. Ne? So you write 10 units. Awesome. So the length of QR is 10 units. Perfect. So we're going to go to 3.2 now. Ne? Okay, so on 3.2, they want us to determine M, the midpoint of QR. So on QR here, there's a point along the center of this line, basically, that is called M, and that is the midpoint. Ne? Remember, midpoint, we use a capital letter, and then you write subscripts here. We're looking for the midpoint of QR. So it's going to be, midpoint formula, it's x1 plus x2 over 2, coordinate y1 plus y2 over 2. And then as we see there, our x1 is -3 here, right? It's -3. And then my x2 is 5 there at the top over 2. And then my y1 is -3 plus my y2 is 3 over 2. And then this becomes, let's see, it becomes what? It becomes 2 over 2, which is 1. And then this one becomes 0 over 2, which is 0. And then that is your midpoint. Ne? So the midpoint is what? It's 1 and 0. And then I can easily tell that it's going to be here exactly on the x-axis, right? How did I know that? Is because of the y being 0. Remember, the y is 0 always on the x-axis. So x-axis is line y equals to 0, basically. Y-axis is line x equals to 0. Okay, let's go to 3.3 now. So here we had 10. Then here we had, let's see, we had 1 and 0. Here we had 10 units. Perfect. Here was 1 coordinate 0. Awesome. So now let's go to 3.3. Okay, 3.3, they want us to determine the equation of a line passing through P and M. So the 2 points that we're going to use is what? It's P, M. So there's a line here, basically. Right, let me just try to do dotted lines. So there's a line there. Get it? And then the equation of a line, remember, it's always y equals to mx plus c. So when they say find the equation of a line, right, you know you need to write your answer in this form. Okay. Firstly, I need to get the midpoint, the gradient of PM. Okay? The gradient of PM. Remember, gradient, we use small letters. So it's going to be gradient formula, x2 minus x1. Then I'm going to call this my ones, and then those ones my twos. Sharp. And be careful, ladies and gentlemen, when you say this is a 1, this one must also be a 1. You can't have a 1 and a 2 on 1 point. That makes sense. Awesome. Now we're going to do our substitution. So my y2, I can see there at the top is 3 minus my y1 is 0 over my x2, it's negative 5. And then my x1, it's 1. Okay. And then here I'm going to have 3 at the top and then negative 6 at the bottom, which gives me negative half. So my m is negative half. Okay. And then we have y equals to, I'm going to substitute the m there, right? Half x plus c. And then when you are in this point, you are going to pick any point that lies on this line, P and M. So I can easily take M, for example, right? So my y is 0. And then my x is 1 on M. And then plus C. And then I can see that, okay, this is still half. So I have 0 equals to negative half, plus C. And therefore, my C is going to be equals to half. Right. Perfect. So now I'm going to say therefore, because I don't have space at the bottom, I'll just write it here. Y equals to negative half x plus half. So my answer is what? Y equals to negative half x plus half. Okay. Awesome. So now we're going to let's do this. I need to erase this part here. Let's see. Is there a way to select all and delete? Okay, so I have to just use an eraser then. Okay. So let's erase quickly. We're going to erase this part quickly, because that other information we're still going to need, right? So we have this, right? Awesome. So now we're going to do 3.4. Okay, so 3.4, let's check it out. So they say determine the equation of the circle which has diameter QR. So basically, the QR is the diameter of this circle that we're looking for, its equation. It's like it's passing through P and Q, and then this is the center of that circle there. So if QR is the diameter, right? It means QM will be the radius and MR will also be the radius. So M is the center, right? Remember the general circle equation is x minus a squared plus x minus b squared equals to r squared, right? Awesome. And then, sorry, here it must be y, ne? Sorry, y, sharp. So now, we're going to have the center, ne? A and B are on the center. So I'm just going to substitute there. So I have x, right? Minus what? A, which is 1, squared plus y minus 0 squared equals to r squared, right? And then from there, to get the r squared, what you do is you can substitute any point that lies on the circumference of the circle. Ne? For example, this point will be lying on the circumference and that point will be lying on the circumference. The other way to do it, since radius is the length, you can just do distance formula between m and r. Ne? You should get the same answer. But the best one to do is this. You can just substitute another point here because this is already in standard circle form. So it's easy to just substitute your x there, your y there, of either this point or that point. They should give you the same answer. So I'm going to take 5 and 3. Ne? So my x is 5. So 5 minus 1. So I substituted 5 there. Plus my y is 3. So I'm going to have 3 minus 0 squared equals to r squared. Then we go to our calculator. Let's see what it gives us, right? So I have 5 minus 1 squared plus 3 minus 0 squared. That gives me 25, right? It means my r, therefore, r squared equals to 25, right? I can also get r. Therefore, r equals to square root of 25, which is 5 units. Awesome. But for the circle equation, we need the r squared, not the r. Ne? Sharp. If the question asked you for the radius, you will just square root and get that. So obviously the diameter will be 10 units. Do you see it? Awesome. And we already had the diameter actually here, I'm realizing. So you could have just divided it by 2 to get the r, and then you square to get the r squared. You see? Perfect. So now we're going to write our circle equation. Therefore, here, ne? I have x minus 1 squared plus y squared. Because there's a 0 there, I'm not going to write it. Equals to my r squared is 25. Then we're done with the circle equation. Ne? Perfect. So now we can go to 3.5. Okay, 3.5. They say, does P lie inside or outside the circle? Okay. Motivate your answer with a relevant calculation. Okay, so ladies and gentlemen, I'm going to show you my idea about this question, right? First, before we start. Okay, so let me get the mouse and create space here. Let's do this, sorry. Okay, I'll just need to erase. Let me write my formula here before we erase. So we have y, we have, what's happening? Okay, we have, we have x minus 1 squared plus y squared equals to 25. Okay, so I'm going to erase this part. Okay, let's see. We're going to erase this part quickly. Awesome, awesome, awesome. Okay, cool. We can move on now. Right. So let's see. Let's go to 3.5. Okay, I was about to give you my analysis of this. Ne? So I have a circle, right? And then there's QP here. I mean QR, ne? Q is this side, R is that side. And then I have a point here called M, the midpoint, or the center. Right. So I'll show you something now. Let's say, okay, let me use different colors. Let's say my first point is here. Then let's say my second point is there. Sharp. So I'm going to do the distance. Okay, let's call this point M with 2 dots. And then this one, we're going to call it M with a 1 line. Sharp. So I'm going to do the distance from this M to that M. Distance from this M to that M. We can easily see here that if a point lies, okay, obviously we have the distance from here to there, which is our what? Our radius, which is 5 units in this case, right? So the idea is this. If this point, right, lies outside the circle, the distance between the center and that point will be bigger than the radius. But if it lies inside the circle, the distance between it and the if this point lies inside the circle, its distance from the center to the point will be smaller than the radius. Awesome. So now I'm going to do the distance between P and M, right? The distance between P and M. Okay. So distance between P and M is equals to, okay, we write the distance formula, of which I'm not going to write, right? Because we already have it written at the top. So my x1, I'm going to make it this again, minus -5. Okay. Then I close that bracket. And then my y2 is going to be 3. And then -0, right? Let's get the answer of PM, the distance PM from the center to P, right? Sharp. So this part I see is still looking alike. But now this part here, okay, I'm going to fix it. So I'm going to delete this 2. Then I have 1 minus -5 squared, right? Which gives me 45, but I haven't put the square root here. So square root of the answer is 3√5. Let's convert it to decimals. So let's see. So the distance is what? Is 6.71. And if you see, this is bigger than 5 units, which is the distance of the radius. So it means we have this case now. We have this case, right? If we have this case, we can say, therefore, P lies outside of the circle. Perfect. So we're fine with that. Now we can go to 3.6, right? 3.6, they want us to determine the coordinate of S. If from P to Q, and then Q to R, then R to S, so S must be somewhere in this side. You see how we name a parallelogram? The way they arrange the order just tells you that we move from P to Q, Q to R, R to S. So my S is somewhere there with X coordinate Y. Okay, so I have something like this basically. Okay, let me just go back a little bit. I'll show you something now. Let's do this quickly. Sharp. I just want to show you, draw like a visual image of this. So I have something like this basically. And then my S is there. Perfect. So now we're going to do this. If this is a parallelogram, remember the midpoint of, okay, let me use a different color. The midpoint of QS must be the same as the midpoint of PR, right? It must be exactly the same. So I'm going to do the midpoint of